Chapter 3-2 continued, substitution method. Strike one, yeah. Substitution method. It's another method used to find the intersection point of two lines out in space as long as they're in the same coordinate plane. Now that is very important. They have to be in the same plane because if they're not in the same plane, then you do not have an intersection point. Now, we've already done graphical. We've already done elimination. We're doing substitution today. When we come back from break, we're going to be doing determinants, which is the absolute most easiest, fun way to do it you can. Serious. I know. Both of our fun. You're going to be like, why couldn't we have just done this the whole time? I'm positive, okay? No. How do you do the substitution method? Now think about it. Substitution, think of a sporting event. One person goes out, and what happens? Another person comes in. Well, that's exactly what this is. But instead of a person, it's going to be an expression. So you're going to choose an equation. And you're going to take that equation, you're either going to solve it for x or you're going to solve it for y. Now, here's the kicker. It is in your best interest to choose the equation whose variable that has a coefficient of 1. Why? Because if you have to solve for x and the coefficient that's attached to it is 3x, that means you're eventually going to have to divide everything by what? 3, which means you're plugging in a fractional expression. And who wants to deal with fractions? Okay. So, this is why it's best to choose coefficients that are 1. Okay? You might not have a choice though. You might be stuck and have to do one that is not 1. So, you're going to solve that equation for the variable you chose, plug that expression into the other equation for that variable, solve for the new variable, and plug the value into the expression that you solved previously. Yada, yada, yada. You don't know exactly anything I just said. So let's try it. Yada, yada, yada. So, example. One more than yesterday. One less than tomorrow. So, what do? I need to choose an equation, but before I choose an equation, I need to look at the equations and say, do I have any coefficients being 1? Coefficients are the numbers in front of the variable, attached by multiplication. So I have a 1y. What else do I have? A 1x, yes? Do we see that? That means that you can choose x or you can choose y to solve for. Equation 1, you could solve for y. Equation 2, you could solve for x. You get to choose. Which one do you want? You want to choose equation 1. And you're going to solve that for what? Good. Notice how I'm writing this down. Why would I want to write this down? So that you don't forget midway through the problem what in the world you did and what you have not used. So, yeah. Quit whining. Okay, the reason why I talk very loudly is because as I'm teaching, I'm projecting my voice so that the back of the room can hear, and the microphone is right beside my mouth. So there, I'll just have it up by my eyeball. Is that helpful? Okay, now, what do? I'm solving for y. Subtract 4x from both sides. So y is equal to negative 4x plus 5. That's y. That is the expression that you'll plug in every place you see a y. The equivalent expression to y is negative 4x plus 5. Does that make sense? So when y goes out, what comes in for y? Negative 4x plus 5. Do we understand that? Now where is it going to go out of? It's going to go, y is going to be taken out of which equation now? Well, what equation have we not used? We've not used the second equation yet. So we're going to take equation 2, which is x minus 2y is equal to 8. Huh? And what are we going to do with it? Every place you see a y, you're going to plug in the lovely little expression, negative 4x plus 5. Do we see that? So now I have x's and x's, right? One variable. Distribute. X plus 8x minus 10 is equal to 8. 9x minus 10 is equal to 8. Because negative 2 times 5 is negative 10. Now what? Add 10 to both sides. 9x is equal to 18. Divide by 9. X is 2. I'll take note of that. Okay. Now, x is 2. Now, what do I do with that? I am going to go right back to my box, and I'm going to plug in what x is. X is the number 2. So this is going to be negative 4 times 2. Negative 8 plus 5 gives me negative 3. I can turn it up a notch for you. Yes, because what is the point of this? The whole goal is to find the point of intersection. A point of intersection requires not only an x-coordinate, but also a y-coordinate. You get me? So what is my POI? Point of intersection is 2, negative 3. POI, point of intersection. It is absolutely gorgeous whenever your coefficient is 1. It is massively, ridiculously ugly when your coefficient is not 1. So shall we do some? Oh, we shall. Actually, how many ounces are in a cup? No, there are 8 ounces in a cup. Okay, so there are many, many, many things out there that only have like 6 ounces in them, so you're going to have to do some math. Sure, you'll use this at the grocery store. Absolutely. You'll use it at the grocery store. I'm sure of it. My husband uses it every time he goes grocery shopping. Just ask him. Actually, he goes grocery shopping an awful lot. He does. I am. I'm very blessed. He does not cook. Yes, he does. I know I am. I'm very blessed. Yes, he does. Okay, what do I do? What do I do? I need to look at my lovely equations and look to see if any of them have a coefficient of 1. Nope. 3, 2, 4, 3. None of them are 1s, are they? So now you just have to pick an equation and then pick one of the variables to solve for. I'm trying to ignore you all. Okay. So what equation should I use? So I'm going to pick equation 1. 3x minus 2y is equal to 16. And what do you want to solve for? Do you want to solve for x? Do you want to solve for y? You want to solve for y. So you're going to write up there what you're going to solve for. No, you may solve for x if you so choose. It does not go into 16. Okay, so now what do I do? I'm solving for y, so I'm going to subtract 3x. Negative 2y is equal to negative 3. Negative 3x plus 16. Now what? We're going to divide both sides by negative 2. Because if you divide by each term by negative 2, you're going to have how many fractions there? You're going to have 2 fractions, and we don't want 2 fractions. We'd prefer just have one nasty, ugly one, right? So I'm going to have negative 3x plus 16 over negative 2. Because we'll have a fraction still. Well, because I'm going to show you something here in a moment. Trust me on this. You don't want to separate them. Okay? Now, we've used equation 1. What have we not used? Equation 2, which is going to be 4x minus 3y equals 23. Can you see it? You can see it, it's just not red, right? What color is it? Okay, it's black, yep. Okay. Now, I am going to substitute in what my y is, all right? So I'm going to have 4x minus 3 times negative 3x plus 16 all over negative 2 is equal to 23. Okay, so now we're going to go ahead and put this 3 over 1. And what you're basically going to have here is negative 3 times the negative 3x plus 16 all over negative 2 equals 23. All I did is I got rid of the parentheses around the whole thing and just kept them around the numerator. Because I multiplied the tops and I multiplied the bottoms. 1 times negative 2 is negative 2. Now, we already took a test over this. If you don't like fractions, what do you do to get rid of it and make it look pretty? You multiply by the least common denominator. And what is my least common denominator here? I only have one denominator. So we're not going to just multiply by 2, but by what? You're going to multiply it by negative 2. So this gives me negative 8x. What happens here? Do you notice that this whole thing is one term? That ugly fraction, it's one big, ginormous, nasty thing. So what happens to the negative 2 I'm distributing with the negative 2 on the bottom? They cancel out, and all you have is the junk up top. Equals negative 2 times 23 gives you? How about that something's negative 46? No, we're not there yet. I have not changed that plus 16 the whole time. Because I haven't distributed that negative yet, Ashley. Are you with me? I haven't distributed the negative 3 into the parentheses yet. No. You do not distribute the negative 2 into this because that is one term. It's one term, okay? What happens? Do we see you can put this over 1, that's gone, and you're left with negative 3? It doesn't matter what you do. You need to understand that it's one term up there. And yeah, it's ugly, but it's still one term. Headache or not, suck it up. I am. Moving on. Negative 8x plus 9x minus 48 is equal to 46. What? It's right there. I know you didn't. Okay, what do I do? I know. I'm sorry, Quinny. X minus 48 is equal to 46. Negative 46. Add 48 to both sides. And you get x is equal to 2. 2. Now you found x. Now what do you got to do? You got to find y. So I come up here, and I have negative 3 times 2 plus 16. Negative 6 plus 16 is 10 over negative 2 is negative 5. I understand. So what's my POI? 2 negative 5. This is what y equals. And then I took that 2, and I plugged it into the x. So negative 3 times 2 is negative 6, plus 16 is 10, divided by negative 2 is negative 5. Now, yes, Michelle. Negative 8x's and 9x's give you 1x. You had, yeah. You good? Okay. Now, obviously, this is massive and ugly when your coefficients are not what? Those. Uno. If I give you the choice like I do on the test, I require you to do one problem using linear combination and one problem doing substitution. On the test, the rest of the problems are your choice. Does that make sense? So tonight's homework is 10 through 18, and that must be done by using substitution. And then 37 through 42, you get to either use elimination or substitution. Now, obviously, folks, if you do substitution when your coefficient's 1, it's so simple and easy. You get me? But if not, you probably want to do elimination. Elimination's quick, and it's more organized, in my opinion. So, shall we go back and answer any questions that you have over get out Friday's homework. Yeah. Not right now. No. Okay. Here is your homework. Answers from Friday. Was there any questions that you did not get right that we need to go over? That's elimination. What number? 36. 36. 6x minus 2y equals 11. Negative 9x plus 3y is equal to 16. Okay. Talk to me. What's the first thing you need to do here when you're doing elimination? You got to ask yourself, are they lined up? X's over X's, Y's over Y's, equal over equal, number over number. They're lined up. Next, the LCM of your X. So what is your least common multiple between 6 and 9? 18. Multiplication tables, people. Not factors, multiplication tables. Now, what is your least common multiple of your Y's? 6. Now, which one is it going to be easier to do? You're going to want to do your Y's, which means you're ignoring your X's up there. So what do I multiply each equation by to get positive 6y and negative 6y? You're going to multiply the top equation by 3 because it's already negative, and the bottom equation by 2 because it's already positive. Do we get that, yes or no? So I distribute 18x minus 6y is equal to 33. Negative 18x plus 6y is equal to 36. No, 32. Now what? Add straight down. Both of those cancel out, and you're going to be left with 0 equals 65. Does anybody find that to be an issue? I find it to be an issue because 0 will never equal 65. So therefore, there is no solution. And what do we know about these lines? The lines are parallel. Yes? Do we understand this, yes or no? Are you talking 23 or 24? 24. Are we listening or are we having our own little conversation over there? I don't like your own little conversation. 3a plus 4b, because it's all about Yoder this period. Negative 3a minus 2b is equal to negative 3. So, what do you notice? The 3a's already cancel out, yes? So those cancel out and you're left with 2b is equal to 6. Divide by 2, b is equal to 3. Do you see that? That would be a problem. I don't know either. Oh, are you befuddled because you think every time you find the least common multiple that that's what you have to multiply each equation by? That's not true. Well, it's not, it wouldn't make it wrong, it's just going to be making it so you're dealing with really big numbers. Yeah. No, what you're doing whenever you're finding the least common multiple is you're trying to get your y values to be a 6 and a negative 6. You're not going to multiply them by 6 and negative 6. You're trying to get y to be 6. So what do you have to multiply this 2 by to get a 6? You got to multiply it by 3. What do you have to multiply this 3y by to get a 6? 2. Does that make sense? Mm-hmm. 27. 27. 3u plus 3v is equal to 15. Negative 2u plus 3v is equal to negative 5. So are they lined up? Uh-huh. And what's my LCD for my x's, or LCM? Is plus or minus 6. What is my LCM of my v's? Plus or minus 3. They're already 3's, aren't they? Because they're already 3's. So you're going to take and multiply the bottom one by a lovely little negative. I recopy the top and bring it down. I distribute the bottom, so that's 2u minus 3v is equal to 5. And I'm going to add them bad boys straight down. So I have 5u is equal to 20. Divide by 5. U is equal to 4. Well, you got that wrong. Now, you're not done because now what do you have to do with that? You have to plug and chug it back in here to get V. So 12 plus 3V is equal to 15. 3V is equal to 3. V is equal to 1. P of I is what? 4, 1. Now, any questions over Friday's homework? If you got them right and you have no problems, bin it. If you got them wrong and you have issues or didn't do it per se, you might want to do it tonight. God, what? You go. What was it?